Now we are going to start with a detailed study of the functional group, that is the carboxylic acid. So as we all know that what is the carboxylic acid, because we have already we are well versed with the basic concepts of organic chemistry. So you all are familiar that what actually is the carboxylic acid. It is just the COOH. And if we want to know its open structure, so it's like that C is making a double bond with oxygen and a single bond with OH. So as far as you can see the formula, I think you can easily get to know that it is actually formed by the combination of two groups, that is the carbonyl and hydroxyl group. So when carbonyl and hydroxyl group club up, they lead to formation of carboxylic acid group. Now if we talk about the general formula, it is particularly CnH2n plus 1 COOH. So what is the general formula? It is CnH2n plus 1 COOH, because here the one you can say, because earlier otherwise it is CnH2n plus 2, but here 1 is replaced by the COOH group. So this is the general formula. So the compounds which contain the carboxylic acid in their chain are actually the derivatives of the carboxylic acid, right. So we have seen actually that carboxylic acid may be attached to a aliphatic alkyl chain. Aliphatic alkyl chain is a straight chain, means there is no ring present. Chain can be branched also, but still you can say that the carbon and carbon are just linked by the single bond, or maybe double or triple bond may be present, but there is no ring like structure. So when carboxylic acid is attached to the aliphatic alkyl chain, that carboxylic acid compound is called as aliphatic carboxylic acid compound. And if there is some aromatic group, or you can say when carboxylic acid is attached to an aryl group, it becomes a member of aromatic carboxylic acid compound. Like suppose we will take a few examples. So this is HCOH. We know that it is, the common name is formic acid, and if we talk about its IUPAC name, it is particularly methanoic acid. So here what you have seen that there is COOH is present and there is no ring like structure. So it is a member of aliphatic carboxylic acid. And one more, CH3COH. So this is my R. R means any number of carbon including in a carbon chain, and there is a functional group, that is carboxylic acid, and its name is, common name is acetic acid, and IUPAC name is ethanoic acid. So it is again there is no ring present, so it is also a member of aliphatic carboxylic acid. Now if carboxylic acid is attached to an aryl group, that means there occur a ring like structure, then it is particularly a aromatic carboxylic acid. Just look at the example. Suppose I have my benzene ring, and to this the carboxylic acid is attached, and the name for this compound is benzoic acid. It is benzoic acid. So when you see that the carboxylic acid is attached to a ring like structure, particularly this is benzene actually, so it is a member of aromatic carboxylic acid. Likewise here you can see there is a side chain of methyl group, but still there is a carboxylic acid group which is attached to a aromatic compound aryl group. So again it is a the member of aromatic carboxylic acid. So likewise we have seen that the compound may contain one carboxylic acid, it may contain two, it may contain three. So likewise we just divide the derivatives of carboxylic acid into monocarboxylic acids, dicarboxylic acids, or tricarboxylic acids, just depending upon the number of carboxylic group which are actually present. So if there is one carboxylic acid group which is present in a compound, it is particularly a derivative of monocarboxylic acid. As you have seen here, in CH3COH there is only one COOH present, so that means it is a member of monocarboxylic acid. Likewise in this benzoic acid you have seen there is one carboxylic acid, so again it is a member of one monocarboxylic acid. Likewise for 2, you have seen that, you know that name of this compound is oxalic acid. When two carboxylic acid are linked to each other, they are particularly called as oxalic acid. So as you can see, there are two carboxylic acid groups. So that means it is a member of dicarboxylic acid. Likewise, there can be two carboxylic acid attached to the benzene in this way. Particularly this name is phthalic acid. This is phthalic acid. So here also you see two kinds of carboxylic acid, so that means it is a member of dicarboxylic acid. Likewise we can have in an aliphatic chain also, we have seen that CH2COH, CH2COH, 2 carboxylic acid group, so that means again it is a member of dicarboxylic acid, and the name is particularly succinic acid. I will write here, succinic acid. So likewise, we have few more examples where more than one carboxylic acid is present. So just according to the number of the carboxylic acid group which is present in a compound, we just divide them into monocarboxylic acid, dicarboxylic acid, and likewise. Now, as far as the isomerism is concerned, we have seen that they particularly show three types of isomerism. One is the chain. You know that what is the chain isomerism? It is that in which suppose you have 5 carbon in a chain, you just try to contract it by making the branches. So what we do, like from the 5 carbons, we are just removing 1 carbon and we are just attaching it as a branched carbon, and like according to that it is called as chain isomerism. As I have an example for you. See, in this case we have butanoic acid. It is CH3, CH2, CH2, COOH. So how many carbon in a straight chain? 1, 2, 3 and 4, right. So now what I can do it, I can make it little branched. So what I have done, I have just removed this CH2 and I have just attached it here to the second carbon. So now the chain is somewhat smaller, but still it has branches now. So now it is called as, earlier it was butanoic acid and here it is 2-methyl propanoic acid. So we can have this kind of chain isomerism in which we just condense the chain and try to make it from the open chain into a branched kind of. Likewise, we can have a functional isomerism. You know that functional isomerism is that in which the functional group totally gets changed. So here what you see is it is CH3, CH2, COOH, that is propanoic acid. Now if I move this to this side, it particularly get converted into this thing ester, as it is CH3, COO, CH3. So this is methyl acetate. So likewise, it can show an optical isomerism also, but the condition required to show an optical isomerism is the asymmetrical carbon. So here we have an asymmetrical carbon. So as you will see, this will be a mirror image of this, and this is particularly a optical isomerism. So I think the basic introduction about the carboxylic group is clear to you, that what is carboxylic acid, what is the general formula, when you call carboxylic acid compound as an aliphatic one and when you call it as aromatic one, what do we mean by mono, di, tri carboxylic acid, and do you have some examples accordingly? You have those now. And likewise, we know that what kind of isomerism it shows. So now it's the time to just start the preparations of carboxylic acid, because once you are familiar with this thing, you must be thinking that how to prepare this carboxylic acid or what kind of reactions can we perform to prepare carboxylic acid. So just look at the book.